Hello everyone, we're going to be building an SDRS scanner for wideband FM broadcasts and narrowband NOAA weather radio stations. It will use a Raspberry Pi with a TFT touchscreen case that looks like this. We'll go through the various parts that you'll need to build the scanner. First, you'll need a Raspberry Pi. You can use either Model 4 or Model 5. Here's the Raspberry Pi 4B, and it has two USB 3 ports that have the blue plastic insulators, and it has two of the USB 2 ports with black plastic insulators, and those are all Type A USB ports or USB jacks. It also has an Ethernet jack as well as some GPIO or general purpose IO pins. Additionally, there's 3.5 millimeter audio jack on the Model 4. That's no longer there on the Model 5. The Model 5 is faster by about 2 to 3 times, according to the manufacturer. We'll look at Raspberry Pi 5, and you can see the GPIO pins on the side. You can see the USB 3 and the USB 2 ports and the Ethernet port. So again, very similar. Also, both of them use a USB-C for power input, and they have HDMI ports, but they use the HDMI micro connect that let you connect a monitor to the Raspberry Pi. And of course, you can connect other peripherals like mouse and keyboard using the USB ports. We'll be putting the Raspberry Pi into a touchscreen case similar to the one that you saw on the scanner, similar to this. Those are available for both the Raspberry Pi 4 and the Raspberry Pi 5. You'll just want to make sure you get the correct one. They come in a box like this and include a stylus and some heat sinks. They include a fan or a cooler of some type, depending on the board that you're getting them for. And they also include the case and the display and a screwdriver that you can use for assembly. And the assembly is fairly straightforward. The more difficult thing is getting the TFT touchscreen to work, but it is possible with some effort, although you may need to do something slightly different from what the instructions indicate. And if we find that that's the case, we found a workaround, and we'll show you how to do that. So because of the HDMI micro video ports, you'll need an adapter, and you'll need your own monitor to start with, because the touchscreen really isn't suitable for development, and it won't work at first in any case until it's set up. So you'll need a cable or an adapter that adapts standard HDMI to this HDMI micro. You'll also need a way to power the Raspberry Pi, and first you'll want an AC power adapter such as this one from Rastec, but there are many others available. It needs to output 5.1 volts and at least 5 amps, and it also needs to have a USB-C connector, or you need some way to adapt that to USB-C to power the Raspberry Pi. You'll also want a portable power supply if you want to make the scanner portable. And here's an interesting one from Anchor that actually has fold-out AC plug, and several companies make those. You want to get one that can supply at least 3 amps, and ideally more at 5 volts or 5.1 volts to power the Raspberry Pi. And that was a lithium-ion battery, and it does have some safety features because there have been concerns with those batteries. We also could use a lithium iron phosphate battery, such as this vest warmer battery, and this one actually has 20,000 milliamp hours, so 20 amp hours in this size, and it has both USB-A and USB-C ports, and If we go back to the anchor, we'll see it has a USB-C port on the side, and it has a USB-C cable. So you'll need the appropriate cables and adapters to power the Raspberry Pi, which takes USB-C. Of course, we're also going to need an SDR, and we've used the RTL SDR Nano 3 from Newelec for its compactness, and it is available in a kit, an on-the-go kit for use with cell phones. And in that kit, it comes with this very compact antenna that plugs into the MCX connector on the Nano 3. And of course, you could use a different model of RTL SDR, but this is a good one. It's very compact. It also has TCXOs, so the frequency stability is 0.5 parts per million, which is very good. The disadvantage of this particular one is it may be difficult to disconnect the antenna from the MCX port without pulling the antenna apart, as just happened there. And that can be done using a pair of appropriately sized pliers. And there are other options for purchasing the Nano 3. Some of them come with most if not all include a heat sink, because it can get very hot. Although it can be used without the heat sink, it will get hotter and might not last as long. So if you get just the standard version, it will also come with the heat sink and this right angle MCX to SMA adapter. Going back to the heat issue, I suggest grasping the Nano 3 by the sides and not by the large faces if you need to remove it after it's been running for a while, because it can get very hot. And it's a little bit cooler if you remove it by the sides, which have some plastic insulation. So what I recommend is instead of using the right angle MCX to SMA adapter or the antenna that has the MCX adapter on or connect, I would use straight through SMA to MCX connector, and that lets you have a much wider variety of choices in antennas, and you can purchase several types of SMA antennas. Telescoping SMA antennas are probably best for this application. Some of them are rather large, which makes them good for use at low frequencies. If you want something more compact and you happen to have tiny SA, it may have come with an antenna that is a little bit shorter, and there are some other options. There are a variety of options available on Amazon, so we'll provide links to at least one of those in the description. So here we have the Nano 3 RTL SDR with the antenna, with that SMA to MCX adapter that you need to get separately, as well as the antenna. And again, those are in the parts list. In addition to that, you'll need a micro SD card to hold the operating system for the Raspberry Pi. So those are readily available. You can find a micro SD or TF card, more commonly called a micro SD card, and you'll need a way to plug that into your computer to write the operating system to it, and potentially to read files from it. So you can get an adapter. Often the micro SD card will come with an adapter that looks like this, that adapts to a standard sized or a larger sized SD card. And you can also buy SD card readers. This is one that has USB-A and USB-C plugs on it, and it has slots for the full-size SD card where you could use your other adapter if you wanted, but there's also a micro SD card size slot on this device, making it very convenient. In addition, it will let you read files from an old SD card and copy them onto your Raspberry Pi while the Raspberry Pi is running from a micro SD card. So it has that capability as well. Additionally, you're going to need some way of interacting with the Raspberry Pi before you have the touchscreen interface working, and even afterwards. For development, you'll want a larger size monitor. So you would, if you have a monitor, I would use that. You can find low-cost HDMI monitors that would be suitable. Again, remember the HDMI micro adapter, or make sure you get a monitor that has a micro SD connector on its cable. So you also need a mouse and a keyboard, and if you want them to be compact, there are options in the parts list. You can also get something such as Logitech mouse keyboard combo that will allow you to use only one USB port for the mouse and keyboard, and so that keeps the other three free, which could be useful if you have other peripherals that you like to connect. The Raspberry Pi OS will indicate when you're running on portable power if the power source is supplying less than 5 amps. However, this scanner application uses much less than that amount of current, and you won't need these yourself necessarily, but we'll show you the current consumption using some meters, one for USB-A and another for USB-C. So that we'll use those as needed so you can see how much current the scanner is actually using. If you're going to package the scanner in a portable way, such as this, you'll want some way to hold it together. And what we've done is use tactical rubber bands that can stretch to over 3 or at least up to 3 times their standard size. So those are very durable, but still not the most rugged solution. They've been good enough for use so far. And the other thing that you will want to have is these rubber feet. Those serve 2 purposes. In this case, they let the scanner stand upright and keep it from slipping. But yet another purpose is that you can put them, as you see here, on the bottom of the case, and they serve as spacers so that there's still some ventilation for the Raspberry Pi when it's mechanically attached to a battery pack such as this. So there should be some space in between for air to circulate so that neither the battery pack nor the Raspberry Pi overheats. There is one more item to mention, and that is that you will need some kind of audio device. Now, the Raspberry Pi 5 does support Bluetooth, so you can use a Bluetooth headset or headphones or Bluetooth speaker, such as this one. In this case, it fits right on the power bank, and this
PC mode.
It can operate in a PC mode where it uses USB for the audio connection, so it does have a USB connector here. In this case, it's connected to the power bank, so it won't have that USB audio, but you can put it in a Bluetooth mode and use that to connect it to the Raspberry Pi to provide audio. You can also get a sound card with a 3.5 millimeter jack on it and a similar kind of speaker that plugs into that. And there is room to put that, depending on how you arrange the SDR and the sound card, there is room to put that on the Raspberry Pi by plugging it into the USB ports. This particular speaker, although it has USB connector, won't fit very well on the Raspberry Pi at the same time as the SDR. The touchscreen comes with a stylus, and that stylus will be very useful to help you use the touchscreen interface. It's possible to use fingertips or fingernails, but much less precise. So here is our scanner application. We'll have to extend the antenna to get very good reception, but it's just because of the location and that we're indoors. We can lower the threshold slightly, put the scanner in scan mode, and find the station, and we've done that. So then we just need to connect the speaker in Bluetooth, and that's something that's the initial connection's best done using a larger monitor.
Bluetooth mode connected.
So now we're able to hear audio through the speaker using Bluetooth, and you can do the same with a set or headphones if you'd like to keep the scanner more compact. And of course you can scan for other stations and find those as well. But this has been a quick overview of the types of parts that you need to build the scanner. And we have some specific examples in the parts list in the description below if you look under more at the bottom of the video. And if you don't like the rubber bands, perhaps they are not the most durable, you may want to substitute something like cable ties. And if they need better grip than just the standard vinyl or other plastic cable tie, you can use something like rubber edge trim or tubing and get some of the grip that you'd have with rubber bands with the greater durability of the cable ties. So I hope this quick walkthrough has been useful, and once you have all these parts, you'll be able to build the scanner yourself, and we'll be showing how to do that in the next few videos, starting with the operating system and software installation, continuing all the way to installation of the specific SDR application software, modification of the user interface in case you want to customize that for the touchscreen for portability, and then we'll give some examples of ways that you can package the scanner for portability and also connect to audio devices as we've seen here. Thanks for your time, and hope to see you soon in another video.